Welcome to this presentation. In this presentation, I'm gonna speak about surgical diathermy. High frequency currents, apart from their usefulness for therapeutic applications, can also be used in operating rooms for surgical purposes involving cutting and coagulation. The frequency of currents used in surgical diathermy units is in the range of 1.1 to 3 megahertz, in contrast with much higher frequencies employed in shortwave therapeutic diathermy machines. The electronic device used to assist the surgical procedures by providing cutting and stopping bleeding is known as Electrosurgical Unit. And this frequency is quite high in comparison with that of 50 Hz main supply, and this is necessary to avoid the intense muscle activity and the electrocution hazards which occur if lower frequencies are employed. The power levels required for the electrosurgery are below the threshold of the neural stimulation, provided that the diathermy frequency is in the radio frequency range. When the frequency is at least 300 kHz, both the phonetic and electrolytic effects are largely eliminated during the flow of the current through the human tissues. This then allows the exclusive utilization of the thermal effect in high frequency surgery, providing both the applications for cutting and coagulation. For their action, surgical diathermy machines depend on the heating effects of the electric current. When high frequency current flows through the sharp edge of the band lobe of the patient of the needle into the tissue. And this diagram shows the basic block diagram of surgical diathermy. And here there is a concentration of current at a particular point, and the tissue is heated to such an extent that the cells which are immediately under the electrode are torn apart by the boiling of the cell fluid. And the indifferent electrode establishes a large area of contact with the patient, and the RF current is therefore dispersed so that very little heat is developed at this electrode. This type of tissue separation forms the basis of electrical surgical cutting. The electrosurgical unit consists of two electrodes, one being called the active electrode and the other being called the passive or dispersive electrode or patient plate. The active electrode has a very small cross-sectional area, whereas the passive electrode has a large surface area. A high frequency electrical current is passed through these electrodes. Due to far smaller cross-sectional area, the current density at the active electrode is far greater than at the passive electrode. As a result of this, the tissue underneath the active electrode is heated up due to destruction. And now let us define the four main terms in surgical diathermy. One is electrotomy. It is a process of cutting the tissues through application of high frequency current. And the second one is fulguration. It is a process of distracting the superficial tissues through application of high frequency current without affecting the deep seated tissues. Coagulation of tissue is caused by the high frequency current flowing through the tissue and heating it locally so that it coagulates from inside. Desiccation. In desiccation, needle point electrodes are stuck into the tissue and then kept steady. Depending upon the intensity and duration of the current, a high local increase in heat will be obtained. And this diagram shows the different electrosurgery techniques that are commonly employed in practice. The concurrent use of continuous radio frequency current for cutting and burst wave radio frequency for coagulation is called Hemostosis Method. And in desiccation, needle point electrodes are stuck into the tissue, and the different types of waveforms have been used to produce different effects for surgical procedures. And now let us see the diagram. These are the typical waveforms. The cutting current usually results in bleeding at a site of incision, whereas the surgeon would require bloodless cutting. The machines achieve this by combining two waveforms, and the frequency of this blended wave is generally the same as that used for cutting the current. So these are the different types of waveforms that have been used to produce the different effects of surgical procedures. The use of the high frequency current offers a number of important advantages. The separation of tissues by electric current always takes place immediately in front of the cutting edge and is not caused by it. Electric cutting therefore doesn't require any application of force. Instead, it facilitates the elegant and effortless surgery. The electrodes virtually mills through the tissue instantaneously and seals the capillary and other vessels, and thus preventing the contamination by bacteria. A simplified method of coagulation saves valuable time since bleeding can be arrested immediately by touching the spot briefly with the coagulation electrode. A high-frequency apparatus is regarded as standard equipment in the operating theatre, and it is kept ready for all surgical interventions, even if high-frequency surgery is not intended, so that use can be made of its superior method of electrocoagulation. Biological tissue can only be cut when the voltage between the cutting electrode and the tissue to be cut is high enough to produce high electric arcs between the cutting electrodes and the tissue. The temperatures produced at the points at which the electric arcs contact the tissues like microscopic flashes of lightning are so high that the tissue is immediately evaporated or burned away. And a voltage of approximately 200 Vp is required in order to produce the electric arc between a metal and electrode of biological tissue. If the voltage is less than 200 Vp, the electric arcs cannot be triggered and the tissue cannot be cut. And the voltage suitable for cutting biological tissue ranges between 200 Vp and 500 Vp. Basically, a surgical diathermy machine consists of a high-frequency power oscillator, and the early types of diathermy machine consisted of spark gap oscillators, whereas the current practice is to use thermionic valves or solid-state oscillators. A majority of the earlier units have access to both these power sources like RF generator and a spark gap generator. The RF generator provides an undamped high-frequency current and which is suitable for making clean cuttings. The spark gap generator produces damped high-frequency current which is specifically suitable for the coagulation of all kinds of tissues. The mixing of both these currents signifies one of the most important possibilities for use in electrosurgery. By blending the current of the tube and the spark generator, the degree of coagulation of wound edges may be chosen according to the requirements. As the detailed waveform and the frequency spectrum varies from one manufacturer to other, the basic concept requires a high temperature arc, possibly exceeding 1000 degrees Celsius. In practice, the cross-section of the arc is extremely small, considerably less than 1 mm diameter, leading to a high current density in the arc. As the heating effect is proportional to the square of the current density, the effect is localized to form the arc. Other factors affecting the rise in temperature are the composition of the tissues and the magnitude of cooling provided by the local blood flow or any other heat transport system. Despite the fact that the surgical diathermy machines have been routinely employed for over half a century, the most significant technological developments have occurred within the past decade only. So, solid-state generators have replaced a substantial number of vacuum tubes and spark gap units. Disposable self-adhering disposable electrodes are now widely used in place of the large area butt plate. A number of design features have enhanced safety, and these features include a variety of circuit integrity monitors like disposable electrode cable continuity, patient circuit continuity, and the alternative path current monitors, among others. The frequency of operation of solid-state diathermy machines is around 250 kHz to 1 MHz, and they deliver about 400 watts in 500 ohm load at 2000 volt in the cutting mode and around 150 watts in the coagulation mode. In coagulation, the burst duration is 10 to 15 seconds and repetition frequency of the burst is 15 kHz. Biological tissue can only be cut when the voltage between the cutting electrode and the tissue to be cut is high enough to produce electric arcs between the cutting electrode and the tissue. So, as I said earlier, voltage of approximately 200 Vp is required in order to produce electric arcs between the metal electrode and the biological tissues. A visible arc forms when the electric field strength exceeds 1 kV per millimeter in the gap and disappears when the field strength drops below the certain threshold level. Biological tissues are coagulated by thermal means if the requisite temperature is maintained around 70 degrees Celsius. So, this diagram shows the different methods of coagulation modes. Soft coagulation is nothing but no electric arcs are produced between the coagulation electrodes and the tissues during the entire coagulation process to prevent the tissue from becoming carbonized. Soft coagulation is recommended in which coagulation controls electrodes are brought in direct contact with the tissue to be coagulated. And the forced coagulation, and this is characterized by the fact that the electric arcs are intentionally generated between the coagulation electrode and the tissue in order to obtain the deeper coagulation than could be achieved with the soft coagulation, particularly when using thinner and smaller electrodes. The electric arcs are deliberately produced between the spray electrode and the tissue so that the direct contact between the electrode and the tissues become unnecessary in spray coagulation. Spray coagulation is used for both surface coagulation and hemostasis of vessels not directly accessible to coagulation electrodes, such as those hidden in bone fissures. This diagram shows the basic building blocks of surgical diathermicion. The heart of the system is the logic and control part, which produces the basic signal and provides the various timing signals for the cutting, coagulation, and hemostasis modes of operation. An stable multivibrator generates 500 kHz square pulses, and the output of this oscillator is divided into a number of frequencies by using binary counters. The frequency of 250 kHz is used for cutting, and to indicate for each mode of operation, Diathermy unit is provided with an audio tone generator. When coagulation output is delivered, 1 kHz audio signal is heard. Similarly, 500 Hz for cutting and 250 Hz for hemostasis. The isolator switch provides an isolated switching control between the active hand switch and the rest of the unit. The foot switch is used to avoid an explosion formed by an anesthesia gases or near electrical contacts. These are the frequencies which are used for timing signals, and 250 kHz signals provide a split phase signal to drive the output stages on the power output circuit. In order to meet the high power requirements, as much as 20 transistors are used in parallel Darlington circuit. Thank you.